We are going to look at a number system conversions, and we will look at the decimal to binary, octal to hexadecimal. Then we shall write a very simple code that helps us to do the conversion from binary to octal and to hexadecimal.
So the reason as to why we need to understand the number system is, first of all, is the technology that we have at hand, which is digital, that limits the computer to only understand the zeros and ones. So things like building logic circuits, you should be understanding how to convert from one number system to another one. And when we shall be looking at different applications of digital circuits, for example, they will be key in doing arithmetic operations, understanding how to encode from different data to and also decoding different data. Things like multiplexing, things like storage management, comparison of different data. So much of this is also used in telecommunication systems, do all those different configurations. So as engineers, you need to understand these number systems in that kind of overview.
Oh, thank you so much, Mr. Brazias. I think at least the members in the class and in this discussion at least have got a hint on why we need to learn these number systems and also know where we are going to apply them ahead of us. Then what about octal? Anyway, maybe an example of a binary number, we can have maybe 0, 1, 1, 1, 0, 0, 1, 1, 0, 1. As long as you see zeros and ones, all these are binary numbers. Or they can be given a base 2 down there. What about octal? This is the base 8. Or the base number or radix. What others call radix is equal to 8. So wherever you hear octal, we are talking about base 8, and that is it. All the numbers that are in base 8 run from 0 to 7. We don't have 8 under base 8. So wherever you see you have a number that has 8, that one can never be octal. But you can express octal from 0 to 7. Meaning you can have maybe 7, 1, you can have 1, 7, 1, 6. All numbers below 8, meaning 9 cannot appear in octal. So 1, 6, 1, 7, 1, 2, all those ones can be in octal. Then maybe you can write it, and if you want to say it is 7, 1, then you're supposed to maybe say 8 or 8.
Excuse me?
Yes, sir.
Sorry to interrupt you.
Yes, Prince.
It's just a simple correction. You said radix is equal to 8?
The base number.
Yeah, so the word radix itself just means the base number of anything. So even the radix could be 2, the radix could be 10, right?
Yes, sir.
Yeah, okay, thank you.
Oh, thank you so much. Here also on base 2, I can also say radix is equal to 2, according to your correction, sir. Thank you so much for that. I was saying if this is 7, 1, I will call it 8. I mean, I put a subscript, and if I write there 8 or octal, I can even write 7 and say octal. That means I'm talking about base 8. But then I cannot also read it as 71. I can read it as 71. Since we said in base 8 we don't have a number that is above. But why do we need to do this? Because even if it is 71, but in its representation in a computer system, it is the base 8 helps us to compress those figures. You could have a lot of numbers, but so the radix is equal to 16. And what does that mean? We are saying this combines basic. This is supposed to be uh, decimal plus hexa, or hexa plus decimal. So this is 6, then this is 10. So hexadecimal, why we are saying it is base 16, because it combines both base 10 and 6. And I don't know whether there is any other person trying to come in. Yes, Nanyunja, I can see your hand is up.
So you people had already looked at decimal or?
Basically, there is a time we had this discussion, but then we are not like we went deep in it, but then we just had an overview, and we had members, some go into deep in some of the computations, which we are going to make a review, because not every one of us at that time also understood. But I will just repeat what I can remember. Then maybe at one point I will also invite Brazias, because he also discussed for us that time. I will add on. So
Okay.
so the only basic information you need to know is that in binary we are talking about zeros and ones. In octal we are talking about base 8, and hexadecimal we are talking about base 16. And the base 16 also starts from 0 up to, we shall move up to 9, because we also we have said it is a combination of decimal and 6. And in decimal we don't have any number greater than 10, greater than 9. I mean greater than 10 anyway. So we have all numbers below 10. So we shall move from 0 to 9. Then we shall move from A to F. That is basically what is available as per now. That is what is in that hexadecimal number system. And we are going to list these numbers. Then we'll be able to understand more. Okay. Now, I can maybe let me write the numbers for hexadecimal. So if I have hexadecimal here, my numbers will run from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of having 10, we have A, B, C, D, E, F. So in the position of 10, we have A. In the position of 11, we have B. In the position of 12, we have C. In the position of 13, we have D. We have 14 in E. Then in the position of 15, we have F. In other words, we also don't have 16. So we are having numbers running from 0 to 15. So that is hexadecimal.
Excuse me, Mr. Martin.
Yes, sir.
Sarah has a question, I think. She's raised her hand.
Okay, let me get back there. Yes, sir.
Excuse me.
Yes, please.
Hexa is also a system on its own, and decimal, thus giving us hexadecimal O.
Oh, okay. I said the hexadecimal is a number system. It is hexadecimal as a
Yes.
number system. But then I said it is derived from a combination of hexa and decimal. If we
So,
to split them into two.
so hexa is also a system.
For now, we don't have it, but it would be there, because we have base 6, we have base 7, but the most commonly used number systems in computing, me, the ones I've seen is 2, then base 8, I've seen base 16, which is hexadecimal. But then you can also have base 6, as you remember in your, I don't know at what level did we do that mathematics, maybe in primary, but I remember we had something like base 2, we had like base 4, base 5. I mean, they were trying to tell you that there are numbers like in base 5, there are numbers that run from 0 to 4. You don't
Mm.
have 5 inclusive. So likewise in base 6, which we could call hexa, you would have numbers running from 0 to 5. But then we find maybe it is not so much important in computing to us, and maybe they find that hexadecimal, if we combined decimal and hexa, it would be so important in compressing huge figures in computing. So to me, that's what I understand. I don't know if Mr. Brasius can add on something.
Okay, yeah, thank you so much. Now, in the general overview of number system, it is just any mathematical representation of numbers. So you realize that different fields, maybe like computer science, electronics, and mathematics, have requirement of which number system works best for their different applications. Now, there are those common number systems that we want to look at when we are doing digital electronics, and these are the binary, which is number 2, that is base 2,
Mm,
the octal, which is base 8,
mm,
the decimal itself, which is common to us,
mm,
and also the hexadecimal. But there are also other number systems, for example, base 4, which is called quaternary, base 3, which is ternary. So our main focus is just on these four. The decimal, which is from 0 to 9. The octal, which is again 0 to
Zero
what? 0
7.
to 7. Yeah. So the idea is that whenever you hear the word base, the base of something, you don't include that number. So if you say
Mm.
base 8, so you don't include the 8. You just start from 0 to 7. So there is a base 10, which is commonly known as the decimal. It is 0 to 9. Binary, which is 0 to 1, that is base 2. Base 8, which is octal, and that is 0 to 7. And then hexadecimal, which is 0 to F. So like Martin said, how do they come up with the word hexadecimal? Hexa comes from the meaning of 6. A shape of six sides is normally called as like a hexa. So they combine hexa with the decimal because it is 0 to 10. Then you add on the other what? The other 6 values. So that makes it what? Hexadecimal.
16.
Instead of you writing 10 after 9, you don't write 10, you write A. So A represents 10, B represents 11, C 13, E 14, E 15, and I mean F is the 15 actually. Yeah. So you just represent those letters like Martin showed you earlier.
Okay, thank you.
Okay, thank you.
Oh, thank you, Mr. Brasius. And here I was trying to summarize your points. So, decimal, we can also remember a decagon. So, this is 10-sided. So, when you combine, that's where you have a hexadecimal, and you have it as 16 number. So thank you so much, Mr. Brasio, and also Sarah. So now, maybe we can look at examples so that we get to understand.